Hello friends, in this video lecture we are going to discuss seepage, phreatic line and C.O.T, that is cut off trench. Okay. Now we know that in case of earthen dam, seepage is unavoidable. So seepage is the movement of water. It is the movement of water from upstream face to downstream face of the dam. Okay. So this stored water finds its way through cracks, fissures, isn't it? Like that. And this water appears on the downstream side. So this is the downstream side. The water gets stored on the upstream side. So this is the upstream side and this is the downstream side. So this stored water, it finds its way through these interstices, pores, cracks, fissures, etc. through the body of the dam as well as through the foundation of the dam, isn't it? So this movement of water from upstream to downstream is called as seepage. Okay. So seepage is unavoidable, but it can be controlled by various means, such as by provision of the cut-off trench, by provision of the filters, by provision of the chimney filters, rock toe, etc. Isn't it? So this is the rock, isn't it? Okay. Now the problem of seepage is this seepage, if it is not controlled properly, then it may create piping through the dam body as well as through the foundation, isn't it? And therefore this piping may lead to the failure of the dam. So this is the first problem. The second problem is that it gives the instability to the slopes as well as the heaving. So due to seepage, there is a slowing and softening of the downstream slope, and the downstream slope becomes unstable, and therefore there is a heaving of the downstream face. Okay, and ultimate the failure of the downstream slope. Okay, and the third important problem due to seepage is there is a excess loss of water. So these are the some of the problems. These are the three main problems, that is the piping through the dam body as well as through the foundation. Then the next problem is the instability of the slope and the heaving, and third is the excess loss of water. So these are the three problems, and therefore it is necessary to prevent the seepage. We can't prevent totally the seepage, but we can control the seepage. So there must be a controlled seepage. which will not affect the dam, which will not fill the dam, isn't it? So we will discuss how to control the seepage in next lecture. But in this, let us sub the term seepage. Now the next term is the phreatic line. So phreatic line is the seepage line, top seepage line, top seepage line. We know that the seepage is just like a flow lines, isn't it? Okay, and this top seepage line, it is called as phreatic line. So phreatic line is the top seepage line. It is also called as seepage gradient line or the hydraulic gradient line. The soil above the top seepage line, above the phreatic line, is considered as a dry soil, and the soil which is below this is called as saturated soil. And the pressure, the hydrostatic pressure below the top seepage line or the phreatic line is a positive hydrostatic pressure, and above it there is a negative hydrostatic pressure. Okay, so the phreatic line is also called as seepage gradient line or the hydraulic gradient line, below which there are positive hydrostatic pressure, isn't it? This phreatic line, it should not cut the downstream face of the dam. If it cuts the downstream face, it means that there is a instability of the slope, there is maybe failure of the dam, isn't it? Ultimate failure of the dam. Okay, and therefore to keep the phreatic line within the dam section, it is necessary to provide the horizontal filter beds or the chimney beds, chimney filters, and the rock top, isn't it? Okay, so remember the phreatic line, it is the top seepage line below which there are positive hydrostatic pressure, and it is necessary to keep the phreatic line within the dam section. And to keep the phreatic line within the dam section, it is necessary to provide rock toe as well as the filters. The filter may be a chimney filter or the horizontal filter, okay, depending upon the soil characteristics. So depending upon the soil characteristics, you have to provide the suitable filter medium, okay, to drain the seepage water. Okay, so this is about the phreatic line. Now the next term is the C.O.T, that is the cutoff trench. So this component, this is C.O.T. Remember, cutoff trench is not the foundation of the earth dam. It is not a foundation. Cutoff trench, it is the trench excavated. It is the trench excavated, okay, within the hearting zone. So this is the hearting zone, okay, or central core. It is also called as central core. So it is made of a impervious type of the material, and this is the outer portion is called as casing zone. It is made with a pervious type of the material. Okay, right? So the cutoff trench, it is the trench excavated within the hearting zone, okay, within the hearting zone, and then it is filled with impervious type of the material, okay. So proper compaction is done. The material which is filled in the cutoff trench, you have to compact it, okay, at the optimum moisture content. Okay. So COT, it is the trench excavated within the hurting zone. More specifically, this cutoff trench should be within the upstream edge of the hurting zone. Okay, right? Now there are two types of the cutoff trench. There are two types of the cutoff trench, or the cutoff trench can be classified into two types. First one is the full cutoff, and other one is the partial cutoff. So the full cutoff, if the trench is excavated, suppose this is a impervious strata, impervious soil, okay, and if the cutoff trench is excavated below the solid rock, below the impervious material, with 30 to 45 centimeter depth, if the trench is excavated in the solid rock for a depth of 30 to 45 centimeter, then such a cutoff is called as full cutoff, and this full cutoff reduces the seepage through the foundation near about 85 to 95%. So 85 to 95% of the seepage is reduced. So the main purpose of the cutoff trench, it is to reduce the uplift pressure or to reduce the seepage about 90%. Okay. So this, it is called as full COT. Okay. Now, if the impervious strata, if the solid rock, such as solid rock, if it is available at a very large depth, under such a circumstances, you have to provide partial cutoff. Okay. So the partial cutoff, and the depth of such a partial cutoff is taken as half of standing depth of water. Okay. So standing depth means what? Half of FTL minus GL. So to this depth, the partial cutoff is taken. Okay. So this partial cutoff reduces the less seepage than that of the full cutoff. Okay, naturally. So it is 50 to 60% of the seepage is reduced due to provision of the partial cutoff. Okay. Now remember, the cutoff walls and the COT and the cutoff trench, these are the two different terms. Cutoff wall is provided here. It is in the form of sheet piling. Okay. So cutoff wall maybe it is provided due to the by impervious materials such as timber, concrete, okay, RCC, steel. Such a material is used for the cutoff walls. Okay. So remember, these are the two different things. The purpose is same, to reduce the seepage, to reduce the entry of the water. Okay. Inside the foundation. Okay. So these are the two terms, cutoff trench and the cutoff walls are different. So COT, the side slopes of the COT may be taken as 4 vertical as to 1 horizontal. 4 vertical to 1 horizontal. Okay, right? So this is about the cutoff trench. So let us summarize. We have discussed the seepage, then the Phreatic line and the COT. Okay. Are you getting this? There are the 3 different terms. Okay. So we will stop here. Thank you for watching.